A legal firm client came to me saying that they have built one GenAI based document mining application. Basically, the any legal professional, they have to put some natural language query there, and they can get the corresponding response, like what are the different articles numbers related to that specific user query, what are the any kind of evidences related to that specific user query, how they can come up with more number of facts, and what are the different kinds of articles numbers, what are the different kinds of precedents are related to each other, in order to come up with, okay, this is the final evidence based conclusion that he can draw for that specific user query. So legal, when I say legal domain, this is not so straightforward. This is a very complex, complicated, because there will be lot of articles, lot of evidences, lot of cases related to that one, which something will be supporting, something will be negating you. So in order to come up with the final conclusion, we need to refer lot of documents, and those documents were stored or the tracked into various forms of files in their complete document mining repository system. So it was working fine, but for some of the cases, for example, there was a specific user query that I want to tell you here. It was about how have our ruling on IP dispute influenced our contract language over last 5 years. So this specific questions, it was retrieving, the system was retrieving the relevant documents, but it was not giving the enough clarity, enough reasoning, how the user can believe its generated response. Welcome back to my YouTube channel, Avigya AI Lab. Since last few days, as I have discussed various kinds of production failure use cases, this is one of them. Here I am going to discuss the difference between RAG and graph RAG, and which scenarios we have to include, we have to use these two technologies. So specific to this question, legal question, when I analyzed, their first conclusion was that the technology should, the specific technique like RAG or graph RAG, it should not be, it is not like that. There are so many talks in the social media. Okay, the RAG is dead now, the next is graph RAG. So is it really that? No, it is not based upon the some kind of era is going on for a specific technology or the tool. It is based on the what is the shape of the user query, what kind of problem statement we are solving. I have always told that the tools and techniques we need to select based upon the use case, based upon the problem statement. So in this session we are going to discuss about in which scenarios we have to select RAG and in which scenarios we have to select graph RAG, and how I resolved the problem statement of this specific legal firm. So in order to get stay tuned with to get this kind of production failure use cases, so do not forget to subscribe my channel, click the hype button, give comment, so that I can improve what should be coming to the next and improve the existing content. Thank you. So now let's understand what's the difference between RAG and the graph RAG. Everyone knows that RAG is retrieval augment generation. Why this is required? Because each time we cannot train our LLM with the required data, but instead we can store our organization specific data in a repository storage system, and that can be used as the source to be used by LLM. So that course, the complete pipeline, how it happens, retrieve it is specific to the user query. It retrieves the information, it adds some additional context on top of that one, and then by using the retrieved documents and the context, then it will generate the response. So this is retrieval augment generation. Simple kind of queries, for example, what was the total revenue last year, and why, what are the various regions which contributed 40% fall or the increase in the revenue. So in that case, okay, what is the total revenue? We can go through some kind of DB querying that is there, that is out of context of this discussion. and what are the different regions which contributed to this specific figure. Then we have to mine the existing document sources. Those are available with us. So for that, a specific, that is retrieval pipelines, when we say, the pipeline says that these are all the steps involved in that pipeline. The first is that document in JSON, and then document, when we say that storage, it happens with the embeddings means through document. When we are storing the documents, we have to perform some kind of chunking might be some paragraph based, page based, even the word based chunking we have to do. Chunking means dividing into small sizes, and then we have to take the embeddings of those. Embeddings means representing those chunks into some higher dimension. When we say higher dimension, we can visualize about 3 dimensions. But if I say that 1526, 3057, something like that, then these are very high dimensional. Why we need this high dimension? Because by representing a single word with this many dimensions, that means the actual context is getting retrieved specific to that specific word. So when the user query comes, we represent our user query in sum of embeddings, and all the documents chunks, those are also getting saved in sum of embeddings. So there are 1526 we can consider, or 3098, 3056 spaces you can consider, and then one kind of similarity between these two entities gets calculated, that is through the cosine similarity, and we get specific number of some specific score, and based on the top case similarity we consider that okay, these are the context retrieved, and these are the like the top case document which are contributing to generate response of our user query. So definitely that indexing happens in order to improve the performance of the document similarity search or those, and after something the final list of documents top case similarities comes, we have to do re-ranking. Re-ranking means we have to rank it which is contributing more to our user query response. So this is very high level pipeline in order to build the RAG, and this RAG is used to answer very fact-based questions. But when it comes like that, for examples, the question is like that, someone asked that how come the company ABC raised its revenue more than 40% as compared to last year. So if I go to check how this happens, then we have to build like that. Company ABC acquired company XYZ last year. XYZ has a team, ML, machine learning and artificial intelligence. This team, AI/ML team, has a new initiative, AI initiative, and this AI initiative, one specific branch, one specific department or one specific branch developed one new AI based applications, and that was entirely new in the industry, which was sold with 3 billion revenue. And this information, that is the relationship between one entities to another one entities, and final gave that okay, this is the revenue generated by company XYZ, company XYZ, which was acquired by company ABC. Internally, the AI/ML department has a team, AI initiative, which contributed in getting this much revenue. So it gives all kinds of relationship between various kinds of entities here. So that is giving us the final answer. So this specific, in order to answer this kind of specific user queries, we have to use the graph RAG techniques. So what is graph? In the form of some nodes and relationship. Nodes, we can say some entities, and what is the relationship between these entities? It owns, it captured. These are some kind of relationship. It builds, this kind of relationship are there, and then finally we are coming up with the final response with multi-hop and reasoning techniques. So this is the graph RAG. You got the examples, what is graph, what is example. Now come up to understand its pipeline. So when I say pipeline, it is kind of, first is that we have to extract the entities and the relationship from all the relevant documents, okay, instead of just blindly chunking it. And then we have to define that, okay, these are the entities and relationship maintained. You have to define the schema for this. Schema means what are the important entities, what are the important relationships we need to capture and put it into there in the schema. So the schema definition, that needs subject matter experts knowledge. It is not kind of schema design principle will be applicable for all the domains present universally, that cannot be applicable. It needs specific subject matter knowledge. So in that perspective, once a schema is designed, then the next step it goes to ingest the data to select some kind of specific graph document and ingest the data and validate that whether as per the requirement expected response all the data into the respective nodes and relationships are ingested and linked with each other. If you are maintaining, no, I am having all these informations, some other kind of tabular data information I want to use as an additional supporting system to this system, that also you can use some tabular data, structured data you can save in some RDBMS system, and you can use that as supporting source for this knowledge graph system. But knowledge graph system, when we say what are the informations there, it gets stored anyway, that will also do some kind of similarity search, and there also we need some kind of embeddings. So what these embeddings happens in embedding system, these nodes, they will be storing some embeddings of their metadata informations. For example, what is the node, what are the different kind of relationship, what are the different data, okay, this is the source document, this is the entity extracted from there, this is the page that reference, all these kind of references, those get saved in the form of embeddings in those nodes. So and then when the user query comes, definitely the similarity embeddings of both user queries and this gets compared with these embeddings present in the node, and one kind of score we get, and the highly confident score, for example top 5, top 7 we consider as the relevant candidate in to generate response for our user query. So here if you compare what is the two different between these two type architecture in RAG, the technique, the challenges comes to get the better performance in the RAG system is to how the chunking happens, because when the chunking happens, it should not be fixed size, the size should be selected, should be considered based upon the context. So we should not lose any context. Generally what happens, the first name we start that fixed site and with some kind of overlap, but why overlap? Because chunk to chunk we should not lose any kind of context. But in sometimes what happens, no, some paragraph may contain some context, may contain one complete paragraph of 20 sentences, and some different context starts with 10 sentences. So in that case what happens, if we consider the fixed size context window, then in that case we may not get the complete context out from a chunk, or there's the possibility is that the context gets corrupted if the complete context is not getting captured. So chunking strategy is very much important while we are going for RAG technique. The second is that some kind of embeddings model. General embeddings models in the generic industry we can consider OpenAI, Gemini embedding models. But if you are going to the highly regulated industry like this legal, there is a separate embedding model, legal bot is there, and healthcare means it's a bio bot is there. Those are specifically designed, embedding models are designed to be worked as the embedding model for those specific industries, for example legal or healthcare like that. And generations, that depends upon the retrieval quality. Each time we have to see that whether what is the we have to measure them through some score. What is the generation, what is the retrieval quality, how we can improve. There should not be any kind of waste. You have to evaluate. I have one YouTube video that is based on the AI search engine, how to evaluate that one, how to remove all the bias. I will share that link, YouTube link here. You can have a go through that, and it will be easy to understand how we evaluate these systems, RAG based systems, and how we can improve that. Now, similar context, if I compare with a graph RAG, then what I can say is that graph RAG, what it needs now, what schema designing is first thing is that selecting the right graph DB for that one. These are the two challenges while trying to get better performance out of the graph RAG technique. Now coming back to the major thing, cost. So cost is like definitely when we are going for graph RAG technique, it's the graph RAG database are expensive as compared to the vector DB database. Vector DB database are not that expensive. There are very free also, we can get few databases we can get at free of cost. So this is one is the graph DB, the complete pipeline processing documents plus the skilled resources are required for that, and processing, because it has to process in order to generate response for a single query. It has to process the complete graph to come up with, that will be through multiple hubs, to come up with a reasoning. Okay, this is the context that will be useful to generate the response. So it needs time, it needs computation power. So while the time computation power is giving, cost will be definitely added here. So cost, graph RAG is costly as compared to RAG, and it is also, it adds latency as compared to RAG. But if your query demands to go through graph RAG, then you should have graph RAG. In some organizations they say that no, our complete pipeline is graph RAG because we are very confident it will give us the best answer. But they have not, they are very rich organizations and they have not compared how much cost it is drawing this specific graph RAG architecture. So in that case, what I would suggest that most of the organizations, they also follow the similar kind of stuff architecture. What they do a hybrid pipeline, hybrid architecture. That means when the user query comes, if this is simple, then it will go through, and if needs some kind of facts information, then it will go through the RAG technique, and if it needs reasoning with multi hubs, then it will go through the graph RAG pipeline. How to do that one? Okay, then it should not be based upon some kind of keywords or the tags present in the user query. This intent analysis should be flexible to understand the actual what intention the user is trying to say. So in that perspective, we have to in that intent and classification tags specific agent, if there is an intent classifier agent is there, then we have to put one low level small language models which will be able to classify the user query whether that should go to the RAG. It contains only simple fact based user questions, and the other one which is complex multi hub which needs reasoning, then that will route to the graph RAG pipeline. The second scenario we can say right now what I said is about the query classification layer, that means intent classification layer. The second thing what we can do is about the parallel retrieval. For example, some kind of ambiguous queries. The query classifier, the intent classifier failed there to classify correctly whether to RAG or the graph RAG. So in that case, what we can do, we can run both retrieval pipelines simultaneously and merge the context. The graph path gives us the relevant document chunks, and the graph RAG path gives structured relational context. Then LLM has to synthesize both and consider that to serve the user query. The third scenario, it will come as the fallback chains. For example, start with the RAG fast and cheap, and if the retrieve context comes under low confidence, that means it is less than a specific threshold, then route it that to the graph rack for deeper reasoning retrieval. So here, by adopting this kind of hybrid approach, what we can do, we can have a robust architecture that is fast, cheap responses for simpler queries, deep and structured reasoning for complex queries, graceful digression if the graph is stale or unavailable, and RAG still. Now the question comes, what are the different tools and frameworks worth knowing? For RAG, we can select LangChain, Llama Index, Haystack. Llama Index is very much, it provides very robust architecture for indexing purpose, because when we use large number of documents, indexing is much more important for faster retrieval. So all have these solid RAG pipelines abstractions. And for Graph RAG, we are having Microsoft Graph RAG library, that is the open source that you can use. The second is Llama Index, Knowledge Graph Index, Neo4j LLM integration with LangChain. This ecosystem is newer and moving very fast. So in 2026, almost all the organizations who have adopted the LLM based GenAI applications in their architecture, they are trying to, there are multiple applications of this. When we say that context management, context engineering, memory management, all these will be retrieved. This needs various kinds of reasoning, multi-hops reasoning. Lots of informations we are captured as part of the context while conversation with the user and the machine. Similarly, memory is also getting accumulated with the each response generation. So all those, and the context window is fixed. So which informations are most relevant, those should be only placed inside the context window. So how this will be getting retrieved? Through proper reasoning. And so these applications of this complete ecosystem based on the graph architecture, that is growing very fast. So here we can say like that, instead of blindly following whether graph RAG is the next generation and RAG is dead now, we cannot say like that. We have to analyze what is our use case, and based on that we have to follow specific technique and hybrid architecture wherever that is possible. So before concluding this session, I have two things. First one I need to say, and second one I need to show you something. The first one, when I want to say is that RAG and Graph RAG are not competitors, but they perform based in specific scenario in their areas, in their own areas. So what I have to do? At first, based upon our knowledge or the experiences, we have to, for a specific use case, we need to try with the simple RAG techniques. And if it, then we need to experiment it, we need to iterate it by following the different types of RAG techniques, different types of chunking techniques, and any specific embedding model is required to generate the embeddings for that one. Next, if that fails and if we feel like that our use case is becoming very much rich in various kinds of reasoning it's expecting, and it's a multi-hop reasoning is required for that, then we can go for the graph RAG. Second is that I would like to show you how this context looks like when we visualize that into some kind of graph database. So for that I have used some use case, my FinOps use case, and where for a specific user query, how the generated context to suffice that specific user query, it is generated, and when in cipher query format, because I have used Neo4j as my graph DB, and once that is generated, that I can copy and paste and run that one in my Neo4j desktop DB instance. Then how it looks, where are all the nodes, and how each node is getting linked with the respective edges. So please comment if you want to get similar kind of, if you are involved into similar kind of projects in your organization, or you are personally doing related to this graph database, graph rag, ontology, then please do comment here. And I'm very much curious to know about your use case, or your how you have improved it, and whether you are facing any kind of challenges. Please let me know. I'm here to collaborate with you. And second point is that any others related information, this will encourage me to create similar kind of contents in future. So let's go to the visualization part as part of my context generated for my user query. And this query I return this, actually I have coded this, how to get this specific query in the terminal itself. So here is my terminal which has generated this specific Neo4j visualization query. And once I copied and pasted it, try to run in Neo4j, then I am getting this visualization. So here you can see like that, okay, what is the query, and what is the relationship, and what is the node for that one. Here what you can say is that these are the relationships. Here you can see included. So here what is the node for that one? It is like occurs in, and then this query is related to applies to SKU, and then included data properties. So here the multi-hub, it is doing the multi-hub reasoning, and how the user queries, this is like these are nodes, or the bubbles are nodes, green and blue, and rest of the things they are the edges, how this is, it does the context looks like. Then by going through, an SME can go through this one and he can validate, yes, this has generated, and all the properties are connected, and the complete context that has been generated. A product, this is a job of a product manager especially. So with this I'm going to conclude this session. Please let me know if you want to understand, if you want to build a hybrid routing architecture having both RAG and the graph RAG, then please let me know, comment here. I am happy to help you there. Thank you.